You should.
Yeah, we're
Yeah.
recording
Okay.
now. Okay, cool.
So, hi Emily. My name is Hope, and I hope you're doing okay.
Thank you.
Do you tell me a little bit about yourself? I guess.
Yeah, sure. Well, my name's Emily Tianshi. I'm going to be a senior at the Cambridge School next year, and
Mhm.
I've been doing research on Torrey pine trees and water for around, this will be my 5th year because I started in the 8th grade. And
Oh, okay.
I love the Torrey pines and I love science, and I'm excited to be here talking about it to you all. And thanks,
Yes.
Hope, for having me.
Yeah, no worries. So I guess my first question would be, what? Why is fog so important for Torrey pines, or how does the Torrey pines, I guess, kind of use the fog?
Yeah, sure. So we really don't get that much rain in San Diego. I believe the statistic is the Torrey Pines State Park receives around 245 millimeters of rain annually. But interestingly, the evapotranspiration rate is 1,024 millimeters, which is almost 5 times larger than the rainfall.
Mm.
And considering that the pines don't have too much groundwater either, the fogs are really, really critical in accounting for that large delta. So essentially, throughout the year, especially in the fall and winter, there's a really thick marine layer that kind of comes through in the mornings, kind of before the sun rises, and as the sun gets there, it kind of disappears. But that fog is really critical to the Torrey pine survival because that's one of their main water sources. How do the pines use it? Okay, that's a complicated question because well, when I went hiking there as a kid, the story that I got all the time was the needles condense it, and then once it gets saturated, it falls on the ground, and then the roots absorb it,
Right,
and that's why we can see the puddles as well.
right.
But in my research, I actually challenged that idea. I found something new. So without going too much in depth, I found out that it actually the needle absorbs it directly. And when
Mm.
the needle is saturated, then that's when that secondary process starts happening. Because that makes a lot of sense. You already have the water on the needle, so why would you get rid of it? It makes so much more sense to just
Right.
keep it in. And then it obviously needs nutrients from the ground, so that's why the secondary process is necessary as well.
Great, I see. So I guess we have my next question would then be, you know, what is the most interesting thing that you have discovered about Torrey pines in your 5 years of research so far?
Yeah, okay, that's a big question. A lot of interesting things in a lot of different fields. And
Or
I guess I'll start from the very beginning. I'll do the
mhm.
basics. So if you've never like gone up and close and personal to a Torrey pine tree, I highly recommend you do it. You'll notice that the needles are actually triangular. There's 3 sides to them,
Mhm.
and they grow in uh, clusters of 5. They're supposed to grow in clusters of 5. To be honest, I see more of them in 3 or 4 than 5, but that's a different story.
Yeah, definitely.
And they're really big too. They're very long and thick. And if you take a look at any of the pines that are local, you'll discover that Torrey pines are just really gigantic compared to them.
Mhm.
So one of my first steps was to take a look at the Torrey pine under the microscope. So okay, I have my microscope with me. This guy. I got
Awesome.
this one in 8th grade. It's like $20 from $20 microscope from Amazon.
Mhm.
I highly recommend you get it because it's a really good microscope for $20,
Right.
up to 800 times magnification. But essentially, I found that there's little white dots called stomata, and they're in really neat rows. Um,
Mhm.
and then I took this onto a better microscope, one that's far more expensive than $20.
Right.
So I ran it under the Keen's 3D microscope and also the ESEM, and
Mhm.
essentially found that the needle has ridges and valleys. So it's not a flat surface, it goes like that. So, okay, so this is
Okay.
the needle going lengthwise.
Right.
The ridges and valleys go this way. And
Okay.
the rows of stomata are inside the valleys.
Ah.
So it's very neat. I've never seen such an organized plant as the Torrey pine.
Mhm.
But that was essentially my first step to see under the microscope. And So the stomata are around 30 to 50 microns in diameter. And okay, how do we convert microns to centimeters? I think 1 micron is 1/100th of a millimeter. I might be mistaken.
Okay.
Okay.
But very small.
Yeah, very small. Um, and then my next step was to essentially analyze the surface properties of the needle. So for background info, hydrophilic means water, um, not necessarily absorbing, but attracting, liking. Philic
Right.
means love, water loving. So like a piece of paper is hydrophilic. Hydrophobic is water fearing. So like plastic, your hair, skin, that's hydrophobic. It will repel it. So I wanted to just to figure out if the Torrey pine is hydrophilic or hydrophobic. And most pine needles are known to be extremely, extremely hydrophobic because they have a layer of wax on the outside called cuticle.
Right.
So yeah, but the way to do this in a really simple manner is literally just to put a drop of water on it. So, okay, so I brought my micro pipette. So you just kind of like do a little drop of water and then look at it through the microscope, take a picture of it, and then I had a software I could measure the contact angles really quickly. Torrey pines are very hydrophilic. That was one of my very first like what is going on findings back like in 8th grade. But the size of the water droplets I used were pretty large. They were around like I'd say like 20 microliters or so. So it covers like a good amount of area, probably like half of one side of the needle.
Right.
I wanted to go smaller. And it's really difficult to have a micropipette that's like really little and have to be accurate, and like my hand shaking, like that's just not a smart method. So instead I took a spray bottle and I kind of like sprayed it up in the air. You know how spray bottles have those like really itty bitty droplets?
Yes.
So I would basically, kind of just random. And then I did it enough times that I got enough contact angle measurements. And I found that stomata are actually really hydrophobic. It's only the ridges that are hydrophilic. So if you can imagine, because they are arranged in such neat rows, this creates a micro pattern. It's alternating hydrophilic and hydrophobic, which is really interesting that it has, because most other pines are just, straight across. And what I think this means for the Torrey pines is that most pines have cuticles that are hydrophobic to prevent water from evaporating because they can't afford to lose any water to the sun. They really need to keep it in.
Right.
But the Torrey pines, because they are so near to that fog source, and if you notice, like there's really not many like naturally growing pines if you drive like just a little bit off of the coast. The rest are just like what is it called? Not man-made, man-grown. And even so, like where I live in Westview, it's like 5 miles away. There's not even that many man-grown because it's so far away from the fog.
Right.
So it shows that the pine needles are really confident that they can get the fog so that they don't mind losing some to evaporation.
Yes.
So that was, the alternating micropattern was a really big finding for me. And then it was during this time that I also discovered that the pine needles absorb it directly, called foliar uptake, where essentially I would spray the water and then I'd look away and it'd be gone. And I was like, oh, where's the water? And I did some control experiments and then realized that it's actually going in. And then I did some other experiments and then figured out the whole, like, first it absorbs, then it gets saturated, and then the whole dripping cycle starts. And then moving to a different stage of my project, this was okay, well, actually, no, backtrack a little bit because I did my project out of order. So I really wanted to see what was going on in live time for the Torrey pine. So like I wanted to video the process of, and I have my humidifier not with me because it's like really messy. I have to run outside. But I wanted to like have the humidifier going and videoing at a microscopic level what exactly is happening. And that's really difficult because your camera lens will fog up immediately. And also water is clear and it makes it extremely difficult to record with the background. It just, you can't see it. So to conquer that, I dyed the water blue so it's really visible under the camera. And
Yes.
then I switched from my microscope to a camera with a microscopic lens. So that way it can be, several feet away, but it can still zoom in.
Right.
And I have a horror story about that too. Like the lens broke like as I was 20 minutes away from my results, and I was really sad, but that's okay. So through that process, I discovered that essentially the water first condenses, after it does the whole uptake saturation thing, then it condenses on the hydrophilic ridges, and then it kind of grows and grows, and when it overflows, then it goes onto the hydrophobic valleys, and then it rolls down.
Right.
So if you've ever researched the darkling beetle, it's a beetle that does essentially the same thing, where it takes in fog, and it's like it's got a shell that's hydrophobic, and then on the shell there's like little bumps that are hydrophilic. And it's very similar. So the hydrophilic bumps collect it, and then it rolls onto the hydrophobic shell, and then it goes like straight into the mouth, like one of those backpack things with the straw.
Yes.
So yeah, that's a cool thing, that a plant and a beetle from I don't know how many miles away from each other have such similar mechanisms because of evolution. That's pretty cool.
Yes.
Okay, so now let's move on to the next part. So I wanted to utilize what I learned from the Torrey pine and apply it onto something that's actually useful.
Right.
A moisture harvesting material or device, like essentially something that can get water from fog for people who need water and are in dry places. So I started my biomimicry process. I wanted to copy that alternating hydrophilic and hydrophobic micropattern onto another material.
Right.
And I searched far and wide for this special method, and it took me a very long time to figure it out. But at the end of the day, I came across transparencies, and I didn't even know what transparencies were until my project. Have you heard of them?
No.
Yeah, they were like really popular like 40 years ago, but it's just like clear plastic sheets, and people used to use them for like docu-cams, where like they would like type things on it, and then they'd shine a light through it to like project it on the wall.
Oh, interesting.
Yeah, I was like, wow, never heard of that before. But I found a hydrophilic transparency, and then I found a hydrophobic ink. So I essentially photoshopped the pattern, and then I printed it out onto the sheet. So that way I had the alternating hydrophilic and hydrophobic. And then I tested like different widths, like how much hydrophilic, how much hydrophobic, what are the dimensions.
Right.
And for the specific materials I used, I found an optimal pattern that actually collected 2.6 times more moisture within an hour than just the homogeneous control. Homogeneous meaning it's like the straight up transparency. So a very significant difference.
Yes.
And what I observed in there is that the water, it condenses on the hydrophilic too. And then because there's the hydrophobic there, it really constrains it from expanding outward. So it forces it to go down. So that way, because there's two processes. First, it has to condense, then it's transported. And because it's so much easier for water to condense on a dry, cold surface than on other water, it's really important that the transportation process is as efficient as possible. And essentially that micro pattern really improved it.
Okay.
And after that, I did a lot of mathematical testing, kind of just to demonstrate the physics behind it. And then I went into device testing, which is where I currently am now, where I started doing prototypes and all sorts of designs, basically, to test out what was efficient. And that's where I went to the park and actually tested it overnight. So the reserve extension, I also didn't know this existed until I did my project.
Really? Okay.
But it's a really isolated trail. So I'd go there like really late at night, drop off my samples, and then come back early in the morning before the sun was out, so that it wouldn't evaporate any of my water, and then test my samples this way. So yeah, that was a very long answer to your question, but yeah, a lot of interesting findings in there.
Out of random curiosity, where was it that you conducted your experiments? Did you do it at home, or did you go to a lab?
Both. So most of it was at home in
Mm-hmm.
my kitchen slash garage lab, because mostly that's just what I needed. I have like a mini fog chamber that's made out of plexiglass, and I have my
Hmm.
own humidifier because I have asthma, so I already had it, so I just used it.
Right.
And especially in the beginning, I didn't really have access to a lab because I'm not
Hmm.
like over 18, so it's kind of hard to have
Right.
access. But for the microscopes, like the fancy microscopes, I
Mm.
did go into a lab and do them. Those were only for like a couple days each.
Okay.
But the part where I said I tested out like the math and the physics behind the
Hmm.
micropattern,
Hmm.
that was also a lab. I
Okay.
went into the lab for around like a week or so, just
Okay.
did all of my experiments. And then the videoing part, uh,
Mm-hmm.
with the camera and the fog, the blue fog,
Mm-hmm.
that was like a whole summer in a lab. So I talked
Okay.
to Torrey Pines Docent Society,
Mm-hmm.
and then there was another guy, a professor from UCSD, who was presenting there the same day.
Mm-hmm.
He's like, "Oh, you can work at my lab." So I was like, "Cool." So last
Okay.
summer, that's what I
I
did. I
see.
just went to his lab, and yeah, he's pretty cool.
Okay. Do you have and so I guess my next question would be how is there anything people can do now to help the drought or Torrey pine and fog drought issue?
Yeah, on a personal level, there's a lot you
Mhm.
can do. You can take shorter showers. You can reuse your dishwater.
Mhm.
Also, laundry water that can be reused.
Mhm.
Also, eat less meat because it takes so much more water to process meat than it does to
Right.
process vegetables.
Mhm.
Um, yeah, just being really mindful of what water you use. And I know this is expensive, but in the long term, it's profitable essentially to
Right.
use like water
Mhm.
saving toilets and stuff like that. Um,
Yes.
but that's just on the personal level. You can do what you can there.
Right.
But there's also a lot of legislation that you can essentially lobby for, and
Right.
petitions that you can sign, and they're all over the internet. And you can get involved in
Right.
organizations too, such as like Charity Water or Water.org or these
Mhm.
really big organizations, and donate to them, and because they provide water for people in third world countries who don't have access.
Mhm. So I guess my final question would be to our future scientists, do you have any advice for them? What would your advice be?
My advice would be to be really creative and think outside of the box. Think about what resources you have available and
Mhm.
think about what you can do with them, because you really don't need fancy equipment or anything like that in
Right.
order to do research. Just start small and go from there. I would also be afraid. I know this is cheesy, but it's just so true. Just don't be afraid of failure. Don't be afraid of
Right.
messing up because it can be really intimidating to get started. And I feel that intimidation all the time. But
Mhm.
like, you miss 100% of the shots you don't take, I guess.
Yeah.
And oh,
Um,
also do a project that you actually care about. Don't just do it for the heck of doing
yeah.
it. Because if you want to do it for a couple years, like it takes up a lot of time and a lot of like
Right.
it takes up like a chunk of your heart, just to put it
Yes,
into
it
a
does.
yeah. So do something you're interested in.
Okay. Well, thank you for having, thank you for being here today, I guess. It's really nice talking to you.
You too. Thank you.
Thank you.
All right, should I stop recording?
Yeah.